So guys, let's continue the revision for the third quarter exam that will be tomorrow. Okay, I give you some examples of questions as we will have in the exam to give you more practice, okay, to be ready for the exam. Let's solve this problem by applying the composite what function. By applying what? The composite function. Here, if the function f(x) as you see equal, okay, cosine square, okay, 4 minus x, okay, I'd like to find the derivative. Find the derivative at x equal 1 or at equal 0, whatever it means. Find the value of the derivative at a given value. Here, as usual, I told you I need to rewrite the function to apply the general power rule, like this one. Rewriting function does not mean the derivative. It will be what? Like cosine, okay, 4 minus x all to power 2. Then apply the general power rule. If you have a function raised to power, I will apply general power rule. I write in different color, okay, what is the derivative here? Derivative, okay, this function, it will be apply the general power rule, which state the power multiply the bracket which is here cosine at the angle which is here 4 minus x, then close the bracket of the angle and the bracket of the inner function here. Multiply the derivative what inside, it is also composite function. What is the derivative of the outer? Negative sign, but please don't forget on this add the same angle which is what? 4 minus x. I think it's clear. Okay, now multiply the derivative what inside, which is what here? Negative 1. Okay, which is what? Negative 1. Then simplify. I write in another color also. Equal what? It will be 2. Look here, 2 multiply negative 1 multiply negative, it will be 2 cosine what? I hope I can write by using the mouse. 4 minus x, okay, clear? Multiply sine, because the negative multiply negative, sine what? 4 minus x. Then find the derivative at this one, derivative at 1. The derivative at x equal 1 is just to replace 2 multiply cosine, okay, 4 minus 1, it will be 3. Multiply sine at the angle 4 minus x, replace x by 1, it will be sine what? 3. That is the result of this question number what? Number 6, because we revised in the first part 5 questions. That is question number 6. Okay, I give you practice on the materials that we learned already in quarter 3. Okay, I hope you understand this problem. Don't forget, before you open the exam, you have to prepare blank paper, okay, calculator, pen or pencil, whatever. Then solve. After you solve, choose the answer like your answer. Try to finish the exam in 45 minutes and let the last quarter hour or the last 15 minutes for revision. Okay, I hope you understand. Now I'll give you another problem. Do you remember the properties of natural logarithmic function? Here, if I gave you another problem, if that is question number 7, I revise with you. Okay, if we have len, okay, x to power what? 3. Okay, find find what? What is the problem? Find. In the exam will be multiple choice, but you have to solve and choose the answer like your answer. Here the derivative at e to power what? 3. That is the question. Okay. I begin with what? I'll begin with finding what? The derivative. But to find the derivative of natural logarithmic function, as I told you before, sometimes we need to use the properties. The properties of what? Natural logarithmic function to make the derivative easier. I remind you by the properties. Here, ln x to power n, it will be what? N ln x. And as you know, this is the first, that is property. Properties of natural logarithmic function does not mean the derivative. Clear? Okay. Ln x, u, function u, its derivative, it will be the derivative of u, the inner, over u. Okay. Ln x, it means the derivative of ln x equal what? 1 over x. Let's solve this problem by using the properties of a natural logarithmic function. Okay, here I will find what? I rewrite the function. Let if y equal. Here the derivative y prime, it will be, okay, 3, I'm so sorry. No, not y prime, I'm sorry. Okay, and this one I'd like to write neatly. Okay, y equal. Okay, let's solve. I rewrite the function first. Rewriting the function does not mean ln here x. I just write the power multiply. Okay, now to find the derivative, it will be the number. Okay, multiply the derivative of ln x, which means 1 over x. But here, be careful. I here multiply. Look, here multiply because it is not a mixed number. It means 3 over x. To find the value of this function, if at e to power 3, okay, it means just replace 3 over e to power 3. Just replace. We can name this one f of x. Okay, to find it the same. Okay, the y, it means f of x, or like this one. This function at the value of x equal e to power 3. Okay, which means here what? F of x, f prime of x. I hope you understand. When we find the derivative of natural logarithmic function, please don't forget the properties which help you to find the derivative easily. Here for question number 8, okay, which also talk about the properties of the function. If we have y equal, look here, ln, okay, e to power x to power 3. So here, then find, okay, find dy over dx, which means the slope or means the derivative rate of change, as you know. Here means it's so easy. I know this property, ln and the natural logarithmic function, which is ln, and the natural exponential function are inverses to each other. The result, it will be what? Here. So rewrite the function, which means x to power. That is the rewritings of the function. Rewriting of what? The function. The derivative of the function, it will be 3x squared. Please don't forget the properties. Don't forget the properties. Okay, I think this one is so trivial. I swear, it's so trivial. The last two questions, yes. If you don't understand anything of this problem, prepare all of the question in the morning to ask in the live session before the exam. I hope to join the session. Question number 9, I have to find the implicit differentiation. Question on the implicit differentiation. Here, find the equation. If I ask you, find the equation, okay, equation of what? The tangent, okay, of which function? I'm sorry for a bad handwriting because I use the curve. Look, to the curve of what? Of function 1, x to power 2 plus 5y to power 2 equals 144. Miss, here to find the equation of the tangent, I'll tell you something. Remember here the equation of any line y equal mx, okay, sorry, plus b. So I need the slope of the tangent m, which means dy by dx. How to get the dy by dx to find the derivative of this implicit function? This is called what? Implicit function. It's called what? Implicit function. So in this case means how to find the derivative of an implicit what? Function. I told you what? 5. I'm sorry. In this case I find the derivative of this function. Differentiate both sides. The first one. What is the derivative of x to power 2 with respect to x? They are agreed. 3 means 2x. Plus, what is the derivative of this one? It will be 10y. Okay? But they disagree. I have to write dy by dx, which equals what? 0. Then separate dy by dx implies what? dy by dx equal. Let 2x go to the other side with different sign. It will be negative 2x over what? Over 10y. Right, in the simplest form it will be negative 1x over, over what? 10 over 10y. Okay? Clear or not clear? Then find the slope, which is what? Replaced by the here it means the tangent at here 1 and 2. The coordinate 1 and 2. Sorry, I forgot to write that the head of the question here. So the slope, it will be what? Replaced by this point, it will be negative 1 over here 5. I'm sorry. 5. I'm sorry. This is 5. It will be over 5 multiplied 2. It will be 10. That is the slope of the tangent at the point 1 and 2. Then replace in the equation here y equal what? The slope here equal negative 1 over 10 multiply what? X, okay, plus b. Replace by the given point also here. It will be what? Replace here. Replace the y by 2. It will be 2 equal. Replace the x by 1. It will be equal negative 1 over 10 plus what? Plus b. Negative 1 over 10 goes to the other side with opposite side, implies b equal what? If you add, it will be 21 over 10. I think it's clear. Then now the equation of the tangent, after I know the slope and the y-intercept, here y equals negative 1 over 10x plus 21 over 10. 21 over 10. If I give you any function and you ask about the equation of the tangent at a given point, as you see here in blue, that is the head of the question. Here it means at, okay, 1 and 2. That is the question in blue. In pink, it is the answer. Okay, clear? Now I have to find the slope, which means dy by dx. But since we have an implicit function, I have to find the derivative by using implicit differentiation. By following the steps, which means differentiate both sides, then separate dy by dx, which means the slope. But to find the slope of the tangent as a given point, replace by the given point x and y in the slope, in the derivative to find the slope. Then find the b. I think all of you know how to complete like this problem. Okay, the last kind of question I'd like to discuss with you, how to find what? How to find the 10th different idea, or the last idea I'd like to revise with you. How to find what? Look here, minimum and what? Maximum. I write abbreviation. Values of what? Of function. For example, fx equals what? X square minus 4x plus 6 plus what? 6. I ask you to find on which interval. I'm sorry, as I ask you the tangent, the equation of the tangent at a given point. Here I have to give you on which interval, 1 and the closed interval. Since we are talking about the extrema on a closed interval, I'm talking about the absolute maximum, absolute minimum, okay, and any absolute, it means relative, but we have a different way for derivative. In this case, what is the procedure that we have to follow? 4 steps. Find the derivative. It's so easy, as you know, because I have to make a table. What is the derivative? 2x minus 4. Then second step, find the critical number, which is 2x minus 4, the values of x when the function is what? The derivative of the function equals 0, since we are talking about polynomial function. 0 implies what? X equal 2. X equal 2 in the given interval, it is what? Critical number. Is what? Sorry, is a critical number. Okay, now third step, in this case on a closed interval, the same steps. I have to draw table. Here it has 3, here x, and here what? Y. It means I have to substitute in the original function, not in the derivative. Okay, the left end here of this one, okay, the critical here the last end, or the right end, here the critical number 2. Replace in the original function 1, it will be 3. 2, if you replace, it means negative 4. 4 minus 8, negative 4, it will be 2. If we replace by 4, 16 minus 16, 0, it will be 6. The greatest value, it will be what? Maximum value. That is what? Maximum value. Okay. The least value, it will be what? Minimum value. Okay. You have, sometimes I ask you where is the values of x at which we have relative maximum or relative minimum. In this case, we will say maximum, where the maximum function occur, maximum at 4, 6, 4 and 6, the ordered pair x 4 and 6. Minimum, absolute minimum, at what? 2 and 2. The least value. Clear or not clear? I hope you understand all of these kind of questions. Thank you for joining. Please revise well this revision plus the others revision, and study from worksheet 1 to worksheet 6 plus any revision I posted on the LMS. Thank you for joining this session. Okay, bye bye.